The diagonal of a TV set is 13 inches long. Its length is 7 inches more than the height. Find the dimensions of the TV set. Make sure to show all of your work to receive full credit. So let's draw a picture so you can get an idea on how to start this question. We have a TV set. It's going to be in the shape of a rectangle. And we are told that the diagonal goes from corner to corner. The diagonal is 13 inches. Its length is 7 inches more than the height. So let's label the height as h, and the length is 7 inches more than the height. We want to find the dimensions of the TV set. So we notice that when drawing in the diagonal, we created a right triangle. And when we have a right triangle, we can use Pythagorean theorem. So we know with Pythagorean theorem that if we have a right triangle, the side opposite of the right triangle, the side opposite of the right angle is the hypotenuse, and we label that with C. And the other two sides are called the legs, and we label them with A and B. The sides can be related to each other with A squared plus B squared equals C squared. So using that formula on our picture would give the hypotenuse being 13 and the legs being h and h plus 7. So we would get the equation h squared plus h plus 7 squared equals 13 squared. And I'm going to simplify this equation by getting rid of the parentheses. H squared is h plus 7 times h plus 7. And 13 squared, that's 169. So we have, when we multiply h plus 7 times h plus 7, we would have h squared plus 7h plus 7h plus 49 equals 169. Let's combine like terms. That would give 2h squared plus 14h plus 49 equals 169. I can see that I have a quadratic, so I'm going to move all the terms to the same side. I'll subtract 169. That's 2h squared plus 14h. And I need to know what 49 minus 169 is. That's a negative 120. So minus 120 equals 0. I want to solve this quadratic equation. Now there are multiple methods for solving quadratic equations, but I typically start with factoring. So I notice that we have all even numbers. So we're going to factor out a 2. We have h squared plus 7h minus 60 equals 0. And now I want to try to factor this trinomial h squared plus 7h minus 60. I need to know the factors of 60. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 6 times 10. And that might be all of them. Oh, I skipped 5. 5 times 12. Okay, so that's the one that I'm going to use because I notice that if I subtract these two numbers, I get the same middle number on my trinomial. So I have 5 and 12, and h times h will give me h squared. 5 times 12 gives me 60. And then I need a plus on the 12 and a minus on the 5 to get a positive 7 for that middle term. Now I can set each factor equal to 0. And I get h equals 5 and h equals negative 12. Now in the context of this problem, having a negative number for the height doesn't make sense, so we can exclude this one. So we're going to use a height of 5. And if the height is 5, that means that the length, h plus 7, will be 5 plus 7, that's 12. So we get the dimensions being 5 inches by 12 inches. Determine the real solutions to the system of nonlinear equations. Our system contains the equations y equals x squared minus 8x minus 1 and y equals x squared plus 15. So when I start a system of nonlinear equations, I like to think of the picture first to get an idea of how many solutions I might have. These two equations are both quadratic equations, and the graph of a quadratic equation is a parabola. I can tell, so they're both quadratic. And if you pay attention to the leading coefficient, they're both leading coefficients of 1. Anytime that leading coefficient is positive, your parabola will be up facing. So we're talking about two parabolas that are facing up. So they might have one intersection point like this. I'm trying to think, maybe you could have one that's really wide and one that's really skinny, and that might give you two intersection points. And I'm not sure with them both facing up if you can make it so that they don't cross each other ever. Maybe you could. Yeah, they might never cross each other. So we might get two solutions, one solution, or no solution for these two quadratics. So now I want to think about what methods I could use to solve this. We can solve, our typical methods are with substitution and elimination. And I will show you both methods, and then maybe at the end I can show you a calculator technique for if you have a graphing calculator, how you can get the answer. So let's try the substitution method first. Now with the substitution method, you want one equation solved for. And when you have that solved for, then you can substitute into the other one. So we already have it set up that we have a variable solved for. So y is solved for, and I can substitute this x squared minus 8x minus 1 into the other equation. that would give x squared minus 8x minus 1 equals x squared plus 15. Now I'll try to collect the x squareds, but you can see when I subtract x squared, it's going to cancel out on both sides. So that's going to leave me with negative 8x plus 1 equals 15. So the x squareds canceled out, and now I have a linear equation, and I'm going to isolate the x. So I'm going to add 1 to both sides. That's negative 8x equals 16. Divide by negative 8 on both sides and get x equals negative 2. So I've got the x coordinate, and I can find the y coordinate by plugging this back into x in either equation. So if x is negative 2, y is equal to negative 2 squared plus 15. Negative 2 squared is 4. Plus 15 gives me 19. So we get the solution, negative 219. So that's with the substitution method. Let's take a look again with the elimination method. So if I were to try this problem with the elimination method, I would take a look at my like terms. I have y's that are both linear, y to the first power. So these are like terms. I will be able to eliminate y if I wanted to try the elimination method. When I look at the x's, I do have like terms with x squared, but I don't have a like term with the x. So I'm not going to be able to eliminate the x from the equation by combining these together. So if I want to use the elimination method, I have to use it on the y. So I want them to have the same coefficient with the opposite signs. Right now they have the same coefficient, both of them with a 1. I'm going to multiply both equations by negative 1, and that will give them the opposite signs. So we have y equals x squared minus 8x minus 1. Negative y equals negative x squared minus 15. Now I'll add the equations together. Y minus y is 0. We've eliminated the y variable. X squared minus x squared. We've eliminated the x squared. Negative 8x carries down, and negative 1 minus 15 is negative 16. Now I can solve for x. I'm going to add 16 to both sides. That gives negative x equals 16. Divide by negative 8. And that gives x equals negative 2, just like we got with the previous method. So let's try substituting this into the other equation this time. So if we substitute it into the other equation, we get y equals negative 2 squared minus 8 times negative 2 minus 1. Negative 2 squared is 4. Negative 8 times negative 2 is 16. 4 plus 16 is 20, minus 1 is 19. So we've got the same solution, negative 219, with this other method. And so then, let me get my calculator open. In case you have a graphing calculator, you can see the technique for finding the solution with that graphing calculator. So with the graphing calculator, you're going to use a graphing feature in the y equals menu. You'll type first of all, you have to have your equations in y equals form. And this question already has both equations in y equals form. So this is a nice example to use your calculator because there's not anything to do ahead of time. So in that y equals form, we're going to type in our y equals menu, x squared minus 8x minus 1. And in the y2, we're going to type the other one, y equals x squared plus 15. So x squared plus 15. And now we're going to graph it. So we can see the picture. We can't see the full picture right now. So I'd like to zoom out so I can see both parabolas. Okay, so there I can see both parabolas. And let's move our cursor closer to where the two are crossing each other. So if I move that cursor closer to where they're crossing each other, you can see I'm getting close to the answer that we got. Okay, I'm going to zoom in. Now you can see that intersection point pretty well. But just moving this point around doesn't tell us what that intersection point is. You can see how many decimal places we have here. So there is a feature in the calc menu called intersection. So I'm going to hit second, trace, and the feature is called intersect. And it's asking me for the first curve. Right now you can see my cursor's blinking on the blue curve, so I'm going to hit enter. Now my cursor's blinking on the red curve, I'm going to hit enter. And then it asks me to guess. And I'm going to move my cursor closer to that intersection point, hit enter, and then the calculator actually tells me what the solution is, what that intersection point is. Negative 219, just like we got in our algebraic techniques. So we have our solution to this system. It's negative 219. Determine the real solutions to the system of nonlinear equations. We have the equation x squared plus y squared equals 9 and x squared plus y minus 2 squared equals 1. So these are the equations in our system. And with nonlinear systems, I like to get a visual representation before I start solving. So I know that both of these equations are circles. And usually circles are pretty easy to graph, so instead of giving a generic sketch, let me actually sketch this. So I've got x squared plus y squared equals 9. That's a circle with the center at 0, 0, with a radius of 3. So we have one circle, and the other circle has a center of 0, 2 with a radius of 1. So 0, 2 would be a center. Let's draw this one in a different color. So we have a center of 0, 2 with a radius of 1. And that would look like that. And what I'm looking for is an intersection point between the two circles. I can see this point right here. 0, 3 is going to be the intersection point. So that one was pretty simple to do graphically. Let's talk about how to do it algebraically. So algebraically, we can do it with substitution or elimination. So if I want to use substitution, I'm going to take that first equation, x squared plus y squared equals 9, and I'm going to solve for x squared. And the reason why I'm solving for x squared is because I have an x squared in the other equation. I'm going to subtract y squared, and that gives me x squared equals 9 minus y squared. And I can substitute this into the other equation. That would give me 9 minus y squared plus y minus 2 squared equals 1. And I'm going to simplify by getting rid of those parentheses. 9 minus y squared plus, and this is y minus 2 times y minus 2 equals 1. I'll give 9 minus y squared plus y squared minus 2y plus 4 equals 1. Start combining like terms. Negative y squared and positive y squared will cancel each other out. I've got negative 2y minus 2y, that's a negative 4y. 9 plus 4 would give me a 13. Equals 1. And now I can solve for y. I'll subtract 13. That gives negative 4y equals negative 12. Divide by negative 4. That gives y equals 3. Now I can get the x by substituting this back in. That's x squared equals 9 minus 3 squared. 9 minus 9 is 0, so x squared equals 0, and that means x equals 0. So we've got our solution, 0, 3. Now I could also try this with the elimination method. So with the elimination method, I would look for terms that I could eliminate. I've got the x squareds being like terms, and the y's are not like terms, so I'm not going to be able to eliminate the y's. So let's multiply a negative onto both sides, negative 1, and then my new system would be x squared plus y squared equals 9. Negative x squared minus y minus 2 squared equals negative 1. And when I add these equations together, the x squareds eliminate, and I have y squared minus y minus 2 squared equals 9 minus 1 would be 8. So we've got y squared. Let's multiply out y minus 2 squared. Y minus 2 times y minus 2 equals 8. That's y squared minus y squared minus 2y plus 4 equals 8. I have y squared minus y squared minus 4y plus 4 equals 8. And I can distribute that minus to all the terms. We have y squared minus y squared plus 4y minus 4 equals 8. Y squared minus y squared is 0. And I have 4y minus 4 equals 8. I'm going to add 4 to both sides. That gives 4y equals 12. Divide by 4, and we get y equals 3, just like we got in the previous method. So we're going to substitute this into y. Let's substitute it into y here. That would give x squared plus 3 squared equals 9. X squared plus 9 equals 9. I'll subtract 9, and we get x squared equals 0, and x equals 0. So we got the solution 0, 3 in 3 different ways. We got it graphically, we got it with the substitution method, and we got it with the elimination method.
Thank you for checking out my videos. Have a great day.